Hi, this episode of Surely Physics is on electrical power. If you just look it up anywhere, P equals IV is what we're going for here. But let's take a quick step back. Power from our mechanics class, you might recall it as a rate of work done. So another way to express this in terms of an instantaneous rate is dw dt. So how quickly is work being done by a force? Our force here is our electromotive force, and while it's not a force in newtons, the electromotive force from a battery is really coming from the static electrical force of repelling and attraction. So electrons are repelled from the negative and attracted towards the positive. Positive holes are repelled from the positive side and attracted towards the negative. So in a circuit, we've got a load resistance, an EMF, you can also call it a V in more general terms, and the current flow, I. So those are our components going into this. So how does that relate to, how does I and V relate to this dw dt? Well, what is the work done in terms of potential energy? Well, work is a negative change of potential energy, and in terms of it's just absolute value type thing where the negative doesn't really matter, we could say this is proportional to du dt, where the U would be an electrical potential energy. Well, how is electrical potential energy related to electric potential? By V and Q. So I wrote this in a particular format here. Electric potential doesn't change, but the Q, the charge moving through any point in the circuit, will be changing. It's the flow of electrons one way, or the flow of the positively charged proton holes in the other direction. So the U is equal to VQ. But what is changing here is the charge. So if we now separate this, or separate differently so that we have the V and then the dq over dt, that is where we get the current, because the rate of change in charge is current. So there we have it. Power equals VI. Applying Ohm's law, we can substitute different values in here. So besides power being IV, it would also be a V times I, and I is V over R, so this would also be V squared divided by R, all right? But V is also IR, so this might also be of the form I squared R, if we substitute an IR for V. All right, so those are your different forms of electrical power. That's it in a nutshell.